Nagtuloy na yun. Okay, so where did we stop? So from the probability volume relationship to what? To entropy probability relationship, diba? Then we had an equation that relates naman entropy and volume, from which again we can use, okay, doon sa mga processes involved in our thermodynamic devices. It's either ano lang naman compression or expansion, di ba? So kapag expansion to, Vf over Vi, mas malaki yung alin yung Vf kaysa sa Vi, ibig sabihin yung delta S mo is what? Positive. Which makes sense, di ba? Kasi nga, pag nag-expand, ang change ng entropy ay positive. No? Or there will be an increase in entropy. Kung compression yan, ano mangyayari dito? Vi is mas maliit compared sa, or rather Vf is mas maliit compared sa Vi. So less than 1 ang value nito, ln of less than 1, it will give you a delta S of negative. Only that, we have to assume that the substance inside the thermodynamic devices is what? An ideal gas. Kasi, we're using ano dito K and what? And R. Diba? So, yun nga lang, we have to assume, kahit wala nakalagay sa problem you can assume that the substance in those thermodynamic devices is an ideal gas. And so we can still use this equation. Understood? So madali lang yun. Halimbawa, delta S sa boiler, delta S sa condenser, di ba? You just have to what? To get the change in volume. Dapat ibibigay ito kung siyempre. Ganun lang kasi. But how come again that NK is equal to NR? What is N here? Mole, di ba? So let's have 1 mole of a substance, or of an ideal gas. What is R again? 8.314 joule per mole. Equal daw yun sa. What is K? 1.38 times 10 to the 23 joule per atom. Okay. What is N? Avogadro's number. 6.023 times 10 to the 23 atoms per sige, try nyo i-compute. Ito ba, 6.023 times 10 to the 23rd? Equal dito? Negative 20 dito sorry. 6.023 times 1.38 na lang. Tingnan mo kung 8.314 yung natas. Tama?
8.17.
Okay. And of course, cancellation of units. Ano makakancel dito? Atoms. Diba? Dito, ano makakancel? Yung mole. So ano yan? Joule per Kelvin. But, okay. Tanggalin na natin yung ano dito. Yung per mole. Kasi ang ibig sabihin nun, sa isang mole, ito na yun, di ba? Gano'ng karaming atoms? Ganito kadami. Hindi na natin ilagay yung per mole dito. Di ba? Kasi nga, dito natin in-account. Ang isang mole, ang equivalent daw, 6.023 to the 23rd. Kaya magiging units nila ay joule per Kelvin dito, joule per Kelvin din dito. Tapos na? Kada? Danda na. Nandiyan yung... Again, either of the two can be used. And perhaps hindi yun ibibigay, you just have to memorize what is N and what is K, di ba? You just have to memorize. And of course, yung R naman, alam niyo na. If you're given the modes, so, what about for, you can use this for typical devices, no? Thermodynamic devices. Having typical thermodynamic devices, those that, what? Don't operate under a Carnot, what? Cycle. Diba? Sige, any questions?
Sir, kung enthalpy na po ba yun?
Hindi pa. Medyo marami na kami na-discuss. You just check it sa video, okay? Now, listen again. This is for typical devices. And for typical devices, ano yung consideration natin? Hindi siya nag-operate under a Carnot cycle. A Carnot kasi, reversible yung mga processes doon. Diba? So, paano pag reversible yung process? Again, this can be used for irreversible processes. Okay? At least for now, makita nyo, pwede siya saan? Sa boiler, sa condenser, and perhaps you may say, pwede siya saan? Sa pump, tsaka saan? Sa turbine. Same way dun sa refrigerators natin. You just have to account saan dun yung compression and expansion, di ba? So, at least for now, but maybe later no, you'll see that delta S is actually 0 sa adiabatic processes. Ibig sabihin nun, hindi siya pwedeng i-apply, or it can be applied, but delta S would be equal to what? To 0. Saan yung mga adiabatic natin? Sa turbine, tsaka saan? Pump, sa engine. Sa refrigerators naman, nasan dyan yung mga adiabatic processes? Sa expansion valve, tsaka doon sa compressor. So delta S says, no, in those processes are actually equal to what? To 0. So ibig sabihin, magagamit lang talaga yung equation natin. Ito equation natin na to. Saan daw? Or ito. Doon lang sa boiler, condenser, tsaka sa condenser and evaporator ng thermodynamic. Naintindihan? We'll explain later na bakit kaya pag adiabatic, delta S is equal to 0. Okay? Perhaps we can consider first again, what about for a Carnot device? Halimbawa yung boiler doon sa Carnot device natin. Carnot engine. Anong process meron tayo doon? Isothermal process, which is a reversible process. Understood? So tandaan to, delta S is equal to what? NK ln BF over VI or NR ln BF over VI. Naalala to? So apply natin ang isothermal process sa Carnot engine. Isothermal T is equal to what? To K, right? And we all know that delta U for an isothermal process is equal to what? To 0, such that Q is actually equal to what? The negative of W. Now, the negative or W is equal to what? Negative sa isothermal NR T ln, naalala ba to? VF over VI. If that's the case, then Q is just equal to what? The positive of this. Diba? And RT ln VF over. Now, what do you notice? Doon sa equation natin ng delta S, may similarity, di ba? Tama? Actually, tingnan nyo, pwede kong gawin to. Q over T is equal to what? N R ln VF over V. Tama? And we know that this entire term is actually equal to what? To the delta. And so we can say that delta S for an isothermal process is just equal to what? The Q, whether that be QH or QL. Dalawa yung isothermal process natin di ba? Sa boiler tsaka sa condenser. Nakuha? Of course, divided by what? Whether that be TH or TL. Siyempre kung sa boiler, ano yun? TH yun. Kung sa condenser, TL. Kuha? So we have an equation for what? For a Carnot device and also for a typical device. And this is actually a simplified equation. Now, pwede ba itong i-apply sa? Pwede ba itong i-apply sa tawag dito? Sa Carnot device? Pwede pa rin. Ito pa rin naman yun di ba? Yun nga lang, again, you have a simplified equation kung reversible or isothermal process tayo. Naintindihan? Question. Now, pwede ba itong gamitin sa irreversible or sa isobaric process? Hindi pwede. Hindi ito pwedeng gamitin. Okay? But later, there is a condition wherein yung reversible tsaka irreversible process ay nangyayari sa isang phenomenon. Anong phenomenon yun? Phase change process. Di ba sa phase change process, habang nagbabago yung, for example, yung ice into liquid water, nagbabago ba yung temperature nun? No, isothermal yun. And at what pressure? 1 atm. Nagbabago ba yung pressure? Hindi din. Kaya nga ang phase change process is what? An isothermal and an isobaric process. Understand? That's why, yung mga examples natin kanina involves what? It involved phase change processes. And so, they can be considered under an isothermal and an isobaric process. Isothermal na, isobaric. Kuha? Yung mga melting of ice, di ba? O sabi ko kanina, isothermal. Pero isobaric din. Hindi nagbabago yung pressure during a phase change. Tama ba ako? But anyway, as I have said here, di ba? Pwede itong gamitin saan? Sa isobaric or isothermal process. Ito. Okay? The equation. Or ito. But this is only true, this only holds true saan? Sa reversible process. Kasi tandaan nyo, kaya yan naging ganyan, nagsimula tayo saan? Sa condition na isothermal. Diba? Kuha? Okay. By the way, meron naman dito. Ito rin yun. Bakit kasi pag pinapakita ka agad, di ba? So, maganda ko. Now, we explained bakit sa adiabatic process, delta S is equal to 0. But perhaps, no? Sa Carnot cycle, di ba yung mga processes doon, reversible. This is only applicable for what? For reversible process. Tama? So kung i-apply mo to sa reversible adiabatic process, adiabatic Q is equal to what? To 0. Diba? Kaya nga, delta S is equal to 0 sa adiabatic process. Pero, hindi talaga, ano lang to, medyo crude to medyo indirect. Kasi isothermal to diba? Tapos bigla mong i-apply sa adiabatic. Mas maganda siguro, i-account yung changes doon sa mga properties. Tandaan nyo, kapag adiabatic process, expansion, ano nangyayari sa volume? Ha? Tumataas. O ano nangyayari sa entropy in terms of change in volume? Delta S increase or decrease? Increase. Lumaki yung volume, di ba? However, in terms of temperature change, ano nangyayari sa temperature kapag adiabatic expansion? I-review nyo. Bumababa. Kuha? So, nagkakaroon ng compensation. Tumataas yung entropy in terms of what? Increase in volume. However, dahil ang temperature bumababa, diba? Bumabagal, marami nga ang places na pwedeng puntahan, pero mabagal naman siya. So overall, ang delta S is equal to what? 2? Ganun din sa compression. Oh, ano nangyari sa entropy nung bumaba yung volume? Bumaba. Delta S is what? Negative. Pero yung temperature, tumaas. Delta S is what? Positive. May compensation, delta S is equal to? Lalabas sa exam. Paano kung isothermal expansion? O, i-account mo yung change ng volume, di ba? O, paano kung isothermal compression? Paano kung isobaric expansion, isobaric compression? Again, you have to account for the change in volume and temperature. Kasi tatanungin, positive ba or negative ang change sa delta S or ang change sa entropy? Okay? Change sa S. We go back to our frequently asked questions. Ang dami na natin na-consider. How do we define entropy quantitatively? Nakapag-derive na ba tayo ng equations? No? Yeah. What about for irreversible processes? Meron tayo for reversible and irreversible, di ba? Like internal energy U is entropy a state function? Ano yung state function? Ano yung path function? Hindi pa natin na-tackle to, pero madali lang to. PV diagram tayo. From state 1 to, for example, state 2. Anong process to? Isobaric. Tama? Meron tayong work dyan, meron din tayong Q. Tama? Meron din tayong ano dyan, delta. Meron tayong ano dito, delta U. Right? May delta U tayo dyan. Meron din Q, tsaka W. Right? Listen. Pero, I can have other paths for me to get state 2. That's one path. From 1 to 2, I can just apply an isobaric expansion, right? Right? Pero I can apply again other paths. For example, I'll begin with, anong tawag dito? Sabihin natin, adiabatic, ano muna? Expansion, di ba? And let's call this as your 1 prime. After an adiabatic expansion, tsaka ako mag-isochoric heating. That's, ibang paths na yung kinuha ko, di ba? Pero, ang final state ko ay 2 pa din. Do you understand? So if I'm going to ask you, ang delta U ba dito sa isobaric? Tsaka yung delta U dun sa 1, 1 prime, and 1 prime to 2, same lang? Yes. Same lang yung initial and final di ba? Delta U sa 1, 2, at delta U sa 1 and 1 prime, plus 1 prime and 2, same lang. Yun yung tinatawag ng mga state functions. Hindi nagdedepende saan? Sa path. It doesn't depend on the path the system took. Delta U would be the same sa 1, 2, and saan? Sa 1, 1 prime, and 1 prime, 2. Because the same yung alin? Yung initial and final state. Pero kung tatanungin ko kayo, yung Q ba dito sa 1, 2, same sa 1, 1 prime and 1 prime 2? Same ba yung Q? No, magkaiba na yun. Yung work ba sa 1, 2, same ba sa 1, 1 prime and 1 prime 2? Magkaiba din because Q and work are path functions. They depend on the path, the system. Para mas madali, yung may mga delta, yun yung mga state function. Yung mga walang delta like Q and work, path function sila. Ang ibig sabihin, kung si delta S ang i-account natin, hindi si delta U ha? O, delta S ang i-account natin. Same ba yung delta S sa 1, 2? Tsaka sa 1, 1 prime and 1 prime 2? I'm taking this 1, 1 prime and 1 prime 2 as a single path ha? Overall. So same ba yung delta S dito? Tsaka dito? Yes. Kasi hindi naman nagbabago yung initial and final state. Kahit ano yung path niyan, basta same ang initial and final, delta S will be the same. Naintindihan to? Like internal energy, entropy is also what? A state function. When will change in entropy be equal to 0? Nasabi ko na, saan? Sa adiabatic process. And you know the reason. Saan pa? Nagiging equal to 0? Isothermal, hindi may value pa ng Q doon, tsaka T, di ba? QH niya, tsaka TH yan, or QL over TL, di ba? Hindi yung 0. Saan? Kapag meron kang cycle. Kasi ang cycle, mag-start ka sa 1, saan matatapos? Sa 1 din. Di ba? O anong delta U doon? 0. Anong delta S doon? 0. Anong delta T? 0. Lahat ng may delta, 0. Naintindihan? Kaya nga, tinan nyo. Madederive natin yung equation last time sa Carnot cycle na QH over TH is equal to what? QL over TL. Di ba na-derive natin yung last time? Meron isa pang derivation nun. Tingnan natin ha. Saan na nakikita dito? Saan ko ba pwedeng ilagay? Dito na lang. Hindi mo makikita. Pero I think kita naman hanggang doon. So sa Carnot cycle, alam natin, pag cycle, ano yung delta S doon? Equal to 0. Delta S ano yun? Total. Yung delta S total na yun, pwede mong kunin saan? Sa delta S na, o sa boiler, plus delta S, ano yung sunod? Sa turbine, plus delta S saan? Sa condenser, tsaka delta S saan? Sa pump. Kuha? Tandaan nyo na ang Carnot cycle ay ano? Carnot cycle ay reversible processes, di ba? Tama? Ano yung sa boiler? Di ba isothermal yun? Reversible, di ba? So ano yung equation ng delta S pag isothermal? QH over TH. Tama? Ano yung sa condenser? E di QL over TL. Tama? Ano yung sa turbine? Ano yung sa turbine? Ha? Bakit 0? Adiabatic yun eh. Ano yung sa pump? Oh, you put this sa left side, magiging negative QL over TL is equal to what? QH over TH. Again, makakancel yung negative doon kapag in-account mo yung sign convention ng QH and QL. And that means QH over TH is equal to what? QL over TL. Well, this is a much easier derivation, di ba? Pero you have to know first yung background about entropy. Okay na? Kung matatapos natin to. Hanggang 6 tayo, diba? Enthalpy na tayo. Sige, after this, next meeting na to, okay? Next meeting, by the way, Saturday, may seat work tayo na. Kaya, attend kayo sa, di ko alam kung sa 4:30 or sa inyo. I-announce ko na lang.
Kung saan yung secret, sir?
Ha?
Kung saan yung secret?
Tungkol sa mga natapos natin.
Carno cycle,
Ay hindi, wala nang Carno. Yung sa na-discuss lang dito sa Gibbs, free energy, and enthalpy. Okay? Makikita nyo ba yung memes dito sa Gibbs, free energy? So, hindi nyo mag-gets kasi hindi nyo pa alam, di ba? Maintindihan nyo yan. What about enthalpy? First, what is enthalpy? Kasi change in enthalpy kaagad, but we always started with the kanina, delta S, bago tayo nag-delta S, entropy muna, di ba? May background muna about entropy. So, kailangan may background muna tayo about enthalpy bago mo i-account yung change in enthalpy. So, enthalpy is what? Mamaya, picturean nyo ito lahat ha, para isend sa group chat. Kanina, hindi na picturean. Pakibasa, enthalpy.
Enthalpy. Internal energy plus the energy needed to contain or isolate the system from the surroundings.
So if I have an expansion container that expands, let's say we have a gas. This gas here has an internal energy. Ano yung internal energy ulit? Kinetic energy ng molecules saka potential energy ng molecules. Tama ba? Now, even more, there was an energy used to isolate that gas from the surroundings, right? Merong energy. Ano yung energy na yun? So, enthalpy, from this definition, is equal to what? The internal energy U plus ano yung energy na ginamit to contain the gas? Kasi tinan mo, kung wala ka nun, internal energy ka lang, di ba? Ibig sabihin that gas will be what? Kakalat yan saan? Sa surroundings. But you were able to what? To isolate it from the surroundings. You were able to contain it. And there is an energy, di ba, needed to do that. That energy is called the what? The PV energy. Basically, dahil dun sa pressure na in-apply mo, di ba? Nagkaroon ka ng volume for that gas. Do you understand? The PV energy. And this is enthalpy. Simple. Okay. Now, Paano niya na-account ang change ng enthalpy? Kailangan magkaroon ng process, no? Just like any other state function. This is also a state function. Kailangan magkaroon muna ng process. So, let's consider an isobaric heating. Pag sinabing isobaric, P is constant. Okay? So, ang isobaric heating to, yung H mo initially 1, yung internal energy mo initially 1, pressure mo initially 1, lahat yan 1, di ba? Nung nagkaroon ng heating, ano na yung mangyayari? Magkakaroon ka na ng H2. Siyempre, ito, U2 plus P2. However, alam natin yung P1 is equal to P2. So if you get the change in enthalpy, that would be what? Delta H is equal to what? Delta U plus P. So we have this equation for change in enthalpy, from which we can say that the heat transferred at constant pressure is also the change in enthalpy. What is that? Naalala niyo sa isobaric process, no? Isobaric heating yan, right? Isobaric process. Di ba delta U is equal to what? Q plus W? Ang delta U ba doon equal to 0? Isobaric? Hindi. So, buo yung equation natin, di ba? So, kung kukunin natin yung Q, magiging ano? Delta U minus ano? Minus W. And we all know that W is what? Negative P delta V, di ba? At constant pressure. So if that's the case, then delta U, Q is equal to delta U plus P delta V. Yun lang, ganun lang kasi hindi. Yung Q na sinupply mo is equal to what? To delta H. Naintindihan? Question? Paano natin nasabi na equal to sa Q na sinupply? Kasi applying again the delta U equation for isobaric process, di ba? Makikita mo, pag in-extract mo yung Q doon, ito rin yung lalabas. Which makes sense naman, di ba? Kasi kung ano yung pinasok mo, yun yung magiging change dun sa total energy. Kasi enthalpy is what? Actually, the total energy, malagyan natin dito, that comprises the internal energy plus the energy needed to contain. So we have a realization that enthalpy, lahat tayo may enthalpy tayo, ha? So maling sabihin na ang total energy ay equal saan? Sa internal energy. Otherwise, we're just what? We'll just burst into the surroundings. Di ba meron tayong pressure because of our body? Meron tayong volume? Oh, that's the PV energy. Plus yung internal energy natin, that would be total energy or enthal. Yun yung pagkakaiba ng internal energy saan? Sa enthalpy. Ang enthalpy, ina-account yung body. Yung PV. Intindihan? Kasi dati no, hindi pa natin na i-account yung mga properties na to. But now, it's time for you to have a grasp of these other properties. Okay? Now we go to Gibbs free energy. We're done with entropy. We're done with enthalpy. Now we consider the Gibbs free energy. Now once we get the delta G na, yun na yung isang criterion na gagamitin natin for us to determine if a reaction is spontaneous or not. Hindi yung delta S universe criterion. The delta G criterion. Yung gagawin. And so we have an equation here. By the way, this Gibbs free energy was derived by, pangalan niya, no? Josh Willard Gibbs. Hindi ko alam, baka ancestor ni John Gibbs yun. But this Gibbs free energy is also another term of dynamic property, which is for me, no, the most interesting one. Why is that? What is Gibbs free energy? That is what? The useful energy available from the system. Ibig sabihin, meron tayong total energy H, tama ba? Right? Meron tayong total energy H. Pero lahat ba nung total energy natin magagamit sa work? Hindi. Di ba? Tingnan nyo sa equation. Kaya yung total energy mo, hindi mo lahat magagamit yun. Kailangan mong i-minus yung alin. Yung, ano tawag dito? The energy of disorder. Ang pinakamagandang example dito, ito, this one. Pag may lagnat ka, mainit ka, diba? Tama? Mainit ka. Technically speaking, kung mainit ka, mataas yung total energy mo. Mataas yung H mo. Right? Kasi yung internal energy mo, di ba, has something to do with the kinetic energy of the molecules. Mainit ka, di ba, ang taas nun? Mataas yung H mo. Pero tingnan mo, mataas na yung total energy mo. Ang ibig mong sabihin nun, marami kang magagawang work. May lagnat ka? Hindi. Kasi malaki yung disorder. Kuha? Hindi porke mataas ang total energy mo, marami ka na magagamit saan? Sa work. Yun yung na-derive ni Gibbs free energy. Na hindi porke mataas ang total energy mo, di ba? Marami ka na magagawa na work. Which is very interesting, di ba? Hindi porke ano pang pwedeng example? Siguro kapag naglalaro ka sa initan, di ba? Mag-basketball ka, mas mabilis kang mapagod, di ba? Kasi mas malaki yung disorder. Kaya nga tinan mo to, yung TS, laging iminaminus. Naintindihan? As you grow old, yung temperature mo, pwedeng hindi nagbabago, pero yung S mo, palaki ng palaki, di ba? Nangihina ka, kumukulubot yung mukha mo, nagkakasakit ka. Kasi yun yung second law, di ba? It all leads to what? An increase in entropy. Diba? And so again, Gibbs free energy becomes very important. Question? So, sa kahit anong system, tandaan nyo to, hindi porke mataas ang total energy, marami kang magagamit ng work. Kasi, minsan, no, not all the time though, mataas nga ang total energy mo, pero mataas din yung disorder. So, kailangan balance, di ba? Okay? So if you get the delta G of this, we get the delta G. Delta G is equal to what? Delta H minus T delta S. And if this is just the G of the what? Of the system, then this is what? H ng alin ng system, Ts ng